For this task, we are given a pile of coins of different values, and we are told to determine the fewest number of coins needed to meet a given amount total. And this is the prototype of our function, which is going to be taking two parameters, the coins, which is the list, and total, which is the amount. And then this function is going to return the fewest number of coins needed to meet total amount. And if total is 0 or less, we return 0. And if total cannot be met by any number of coins we have, return -1. And then coins is a list of the values of the coins in our possession. The value of a coin will always be an integer greater than 0. So let's imagine that we have a list of coins with the value in dollar, let's say $1, $2, and $5, and we want to make a total of $11. So option A, we are going to pick $1 coin 11 times to make total of $11. So here that you see that we pick $1 11 times to make total of $11. Then option B, we can pick $5 and then $2 coin, $2 coin, another $2 coin, which is going to make $11. And then for option C, we can pick $5 coin, another $5 coin, and then $1 coin, which is going to make another $11. So in option A, we can see that we picked $1 11 times to get a total of 11. And then in option B, we picked 4 times to get a total of 11. And in option C, we picked 3 times. So the minimum or fewest number of coins needed to get to 11 is 3, which is option C. So the problem is saying that if we cannot get the total amount by adding the number of coins, that we should just return -1. I have a total amount of 37, and then the list of coins we have 1, 2, and 25. And then in our main, we are passing the list of coin and the total to this make change function, and we are printing out the output. So first we are going to check if the total is 0 or less. If it's 0 or less, it means no coins are needed, so we just return 0 as the problem required. So we say if total is less than or equal to 0, we return 0. Then we are going to initialize a variable called remainder with the value as total. So this remainder will be used to keep track of the remaining amount that needs to be covered by the coins. And secondly, we are going to initialize another variable called coins needed with the value of 0. So we say coins needed with the value of 0. So this coin 0, we are going to use it to keep track of the number of coins that we have used. And then we are going to initialize another variable called coin index with value of 0. So we say coin index with the value of 0, and we are going to use it as an index to iterate through the sorted list of coin value or denomination, because we are going to sort this list of coins. So we are going to create a list variable to hold the list of coins sorted in descending order. So I'm going to call it sorted coins list. Now passing coins and then reverse through, so that this way it's going to be sorting it in descending order. So we are sorting in descending order because we want to consider the larger coin denomination first before any other before the other ones. Example, if you have a total of total amount of 8 and a list of, let's say, 5 and 3. So if we sort in ascending or in descending order, we can subtract 5 from 8, which should give us 3. And then if we subtract 5 from 8, which should give us 3, then we can try to subtract 5 again, but it's not going to work. So what we can do is, now we know that we have 3, we subtract 3 from 3, which will give us 0. Now we know that the fewer number of coins that we need to make 8 is now 2, because we only did this subtraction twice. But assuming that we sorted in ascending order, and then we want to subtract 3 from 8, we are going to get 5. If we try subtracting another 3 from 5, we are going to get 2. And then if we try to subtract 3 from 2, it's not going to work for us. So which means this is going to be returning a false negative. False negative meaning that you can't be able to make total amount of 8 from 5 and 3, which we all know that we can be able to do it. So that's of the reason that in this solution that we are trying to create, we are going to be sorting in descending order. So moving on. Next, we are going to calculate the length of the coin list, and we are going to store it in a variable. I'll call it list length. So this list length will be used to control the loop based on the number of coin denominations. Then we are going to use a while loop to iterate as long as the remainder is greater than 0, because initially the remainder is same with the total. The total here is 37. So we are going to say while remainder is greater than 0. So since we will be subtracting, we will only break out of the loop when the remainder is 0 or less. That's what we are saying here. Again, we are going to use a check to see if all coin denominations have been considered. That is, if this coin index is equal or greater than the length of the coin list. We know that this coin list, the length is 3. So the highest index of this coin list is going to be 2. So we are going to be checking if the coin index is equal or greater than the length of the coin list. So we say if coin index is greater or equal to the length of the coin list. So if this is true and the remainder is still not 0, it means that it is not possible to make change of the total amount from the given coins in the list. So in this case, we just return -1. So next, we are going to check if the coin excuse me, at the current index can be subtracted from the remainder without making it 0 or negative. So we say if remainder subtracts the coin list, and then we pass in the passing the coin index if it's greater or equal to 0. If we can do this without having the remainder as a negative number, then we can go ahead and subtract the coin at that index from the remainder. So we say remainder subtracted by sorted list, and then we pass in the coin index. So now that we have subtracted the coin from the remainder, we have reduced the remainder, and in return you will increase the coins needed by 1. So we say the coins needed plus equal to 1. So by doing so, we now know that the coins needed to make change of the total amount so far is 1. This is going to continue until we come to a point where the coin can no longer be subtracted from the remainder and, and still keep the remainder positive amount. Then if this is so, we go to the else block. We go to the else block, and then in this else block we are going to increment the coin index by 1. That way we're going to say coin index, we increase it by 1. So that way we try subtracting the coin at the next index from the remainder. So this is going to continue until the remainder is 0 or coin index is greater or equal to list index. Then we return the number of coins needed. Return coins needed. So let's go ahead and let's go through this again. So where you know that total is 37, here initially they are 0 0. So here you know that after sorting the list in reverse, we are going to have 25, 2 and 1. So and the length of the list is 3. Here the remainder initially is going to be 37, and here again the remainder will be 37, and here initially the coin index is going to be 0. So now let's go through this again. So here you know that the remainder is 37, which is the total. So the sorted list in reverse is 25, 2, 1. The length of the list is 3. Remainder is 37, and here we are still at index 0, which is less than the list length, which is 3. And then here we are checking if we can subtract so now when we enter this loop, we see that remainder is greater than 0. Yes, we are at index 0 and is less than the list length, which is 3. We come here. Can we subtract 25 from 37, which is the remainder, and the remainder will be positive? Yes, 12 will be positive. So we do it. Now the remainder will be 12. So when we do that, we increment by 1. So we come back here, we check remainder is greater than 0, which is 12, and we are still at index 0, which is less than 3, length of the list. Now we check, can we subtract 25 from 12? No, we cannot do it. So we are going, the loop is going to skip this part and then come to this else block and increment index by 1. And then we come back here, remainder is still 12. Is it greater than 0? Yes, but we are now at index 1. Is index 1 less than the length of the list? Yes, it is. Then we check. Now we are going to be checking if we can subtract the coin at index 1, which is 2, from 12, and then we have a positive number. If we do it, we are going to get 10, which is a positive number. So remainder is going to be 10, and here we are going to increment by 1, which is 2. And then we come back here, remainder is 10. Is it greater than 0? Yes. Is the coin index greater than the least length? No. So we come here and we check, can we subtract 2 from 10 and have a positive number? Yes. So when we do it, the remainder will be 8. And now we increment the coins needed by 1, and we have remainder as 8. So is it greater than 0? Yes. We are still at index 1 less than the least length. Can we subtract 2 from 8, which is the remainder, and have positive number? If we do it, we get 6, which is a positive number. So remainder is now 6. We actually do it, your remainder is now 6, and we increment this by 1, which will give us 4 here. Come back here, remainder is 6. We are still at index 1. We come here, can we subtract 2 from the remainder, which is 6, and have a positive number? If we do it, we get 4, which is positive number, and then we get remainder as 4, and then we increment by 1 here, coins needed. Then we come back here and check. We know that remainder is still 4. Is it greater than 0? Yes, we are still at index 1. We come back here. If we subtract 2, which is the index we are at, from 4, which is the current remainder, can we get a positive number? Yes, we can get 2. So when we do it, remainder is now 2. And then we increment this by 1, which will give us 6. Remainder is 2. So we check again. Is it greater than 0, which is remainder? Yes. We are still at index 1, which is less than the least of length. Is the remainder, if we subtract 2, which is the current index we are at, from remainder, which is 2, can it give us 0 or anything greater than 0? Yes. So when we subtract it, now remainder is 0, and then we increment this by 1. So now we come here and check, is remainder greater than 0? No, it's not greater than 0. So we break out of the loop, and here what we're returning, it should be 7, because we're incrementing by 1. What we're returning here is now 7. So if we run this, so we see that we got 7.